Hello. As promised, I'm going to finish up today's lesson working several applications. So my only bullet today is that we're working applications of linear equations. Trevor went on the Pudgkins diet. From the day he began the diet through the next 120 days, Trevor's weight loss was utterly linear. Trevor's weight on the 35th day of the diet was 211 pounds, and his weight on the 100th day of the diet was 185 pounds. What was Trevor's weight the day he started the diet? On what day did Trevor's weight fall below 200 pounds? Well, good golly, there is a whole lot of information there, and there's a couple of questions. Let's begin sorting it out. I think we can begin this problem by finding an equation that describes Trevor's weight. If we get an equation that describes Trevor's weight, I think we'll be able to answer the two specific questions. Before we can find an equation, I think we need to define some variables. So let's go about doing that. Let's let W represent Trevor's weight, which we're going to measure in pounds, T days after he started the diet. Now, since Trevor's weight is going to depend upon the number of days he's been on the diet, I think our independent variable is the T, and our dependent variable is W. In other words, if we were looking at a graph, T would be on the horizontal axis, W would be on the vertical axis. So our ordered pairs are going to have form TW. Let's go back to the problem statement and see if we can find some points that would be on this graph. I'm reading the problem, and the first time I'm seeing something that's going to give me a point on the graph is where it's saying that Trevor's weight on the 35th day of the diet was 211 pounds. That tells me W is 211 when T equals 35. On the 100th day of the diet, Trevor's weight was 185 pounds. That tells me that W equals 185 when T equals 100. So there's 2 points that are on this line. So we have two ordered pairs that are on our line. The ordered pairs 35, 211, and 100, 185. If we want to find an equation for this line, the first thing we need to do is figure out the slope of the line. So I'm going to calculate the slope, including units, in my calculation. So the slope is going to be, I'm going to think of the second point as my x sub 2, y sub 2 point. So that's going to give me 185 pounds minus 211 pounds in the numerator over 100 days minus 35 days in the denominator. 185 minus 211 is negative 26. So I have negative 26 pounds over, it looks like, 65 days. I think this slope will be more meaningful if I change it to decimal form. So I'm going to get out the calculator, and I am going to find what 26 divided by 65 is. 26 divided by 65 is 0.4. So my slope is negative 0.4, and the units are pounds per day. Can you think of what this slope tells us? It tells us that Trevor lost weight at a rate of 0.4 pounds per day. Now let's go ahead and find our equation. So we just found that the slope is negative 0.4 pounds per day. All we need to come up with the equation is a point on the line. Well, we've got points aplenty. I think I'm going to use this point right here. So the form of the equation of the line is going to be W minus W1 equals m times t minus t sub 1. Plugging in my values, I have w minus 185 equals negative 0.4 times t minus 100. Distributing on the right, I have w minus 185 equals negative 0.4t. A negative times a negative is going to give me plus 100 times 0.4 is 40. And then when I add 185 to both sides of the equation, I get w equals negative 0.4t plus 225. Now, before I get around to answering the specific questions, I think I am going to check this equation. So let's check the point I didn't use in this equation and make sure it satisfies the equation. If t is 35, then the value of w is negative 0.4 times 35 plus 225. Let's get out our calculator and make sure that this arithmetic simplifies to 211. So I'm going to take 0.4, turn it into a negative, multiply by 35, and add 225. I end up with 211. That's what I wanted to end up with. My equation works. Now let's answer our questions. What was Trevor's weight the day he started the diet? Well, the day he started the diet, the value of t was 0 because he had been on the diet for 0 days. If t is 0, I can see right from the equation that w is going to come out to be 225. The day Trevor started the diet, his weight was 225 pounds. On what day did Trevor's weight fall below 200 pounds? This is an inequality question. I want to take my weight formula, which is negative 0.4t plus 225, and figure out when is that less than 200. Subtracting 225 from both sides of the inequality, I have negative 0.4t is less than negative 25. Dividing both sides of the inequality by negative 0.4t, on the left I'll have negative 0.4t over negative 0.4. I'm just dividing by negative 0.4, not negative 0.4t. On the right, I'm going to have negative 25 divided by negative 0.4. I'm dividing both sides of an inequality by a negative number. Hopefully, a red flag's going up in your head. We need to change the sense of the inequality. That less than sign needs to become a greater than sign. T needs to be greater than 25 over 0.4. Let's get out our calculator. 25 divided by 0.4 is 62.5. T needs to be greater than 62.5. Before I state a conclusion, let's make sure this answer makes sense. On t equals 62, w equals minus 0.4 times 62 plus 225. And on t equals 63, w equals minus 0.4 times 63 plus 225. Let's show that the first weight is over 200 pounds and that the second weight is less than 200 pounds. So the first weight is 0.4, change the sign, times 62 plus 225. The first weight is 200.2. And contextually, that's 200.2 pounds. You know what? I'm not going to use my calculator to get the second weight. On the second weight, another day has passed. Trevor loses weight at a rate of 0.4 pounds per day. So on day 63, Trevor's weight must be 0.4 less than 200.2. That's 199.8. Yes, indeed, Trevor's weight fell below 200 pounds sometime between the 62nd and 63rd day. So what's my conclusion? Trevor's weight fell below 200 pounds on the 62nd and a half day of his diet. New problem. Uncle Jeb has a problem. He has buckets and buckets of unused grease that contains 23% trans fat. The government is encouraging him to cut the trans fat in his grease to at most 20%. Unfortunately, the only trans fatty grease currently available is 15% trans fat. Not wanting to waste his old grease and not wanting to affect the flavor of his chicken more than necessary, Uncle Jeb wants to mix 23% trans fat grease with 15% trans fat grease to produce 20% trans fat grease. Let's find an equation that relates the amount of each type of grease Uncle Jeb should use in his mixture. See that last word, mixture? Remember working mixture problems? I've done some preliminary work to save time in this lesson. I've gone ahead and defined the variables for us. Let's let X represent the amount of 15% trans fat grease used, measured in gallons, and Y represent the amount of 23% trans fat grease used, measured in gallons. The next thing we did when working mixture problems was we made a table to kind of summarize the data. So in my table here, I have 3 rows, other than the heading row. The 3 rows are the 3 different types of grease. I defined X to be the amount of 15% trans fat grease used, and Y to be the amount of 23% trans fat grease used, both of those measured in gallons. Since I'm mixing together those 2 greases, the amount of 20% trans fat grease I'll end up with is X plus Y. How much trans fat is in each of the 3 greases? 15% of X gallons would give me 0.15 X gallons of trans fat. 23% times Y gallons would give me 0.23 times Y gallons of trans fat. 20% times X plus Y gallons would give me 0.20 times X plus Y gallons of trans fat. The 2 amounts of trans fat that are contributed by the 15% and 23% greases must add up to the amount of trans fat in the 20% grease. In other words, my equation is 0.15x plus 0.23y equals 0.20 times x plus y. Let's solve this equation for y. So I'm starting with 0.15x plus 0.23y equals 0.20 times x plus y. Distributing on the right, I have 0.15x plus 0.23y equals 0.20x plus 0.20y. I want to isolate y on the left, so I'm going to subtract 0.15x from both sides of the equation. That gives me 0.23y equals 0.05x plus 0.20y. Let's subtract 0.20y from both sides of the equation. That gives me 0.03y equals 0.05x. To isolate y, I need to divide both sides of the equation by 0.03. That will leave me on the left with just a y. On the right, I've got 0.05 divided by 0.03. If I multiplied the numerator and denominator of this fraction by 100, what I would finally end up with is y equals 5/3 x. Now, who thought such a simple equation was going to emerge from our equation that was loaded with decimals? Not me. I've gone ahead and produced a graph of this equation, so I guess I probably did anticipate that it was going to turn into y equals 5/3 x. Let's check a point from the graph, but let's check it in the context of the problem. Now notice that I've put an open circle at the origin. That's because while the point 0, 0 satisfies the equation y equals 5/3 x, it doesn't really make sense in this problem in the sense that if he doesn't use any gallons of either type of grease, he's not going to end up with any gallons of 20% grease. But still, I can orient myself from the origin, and I have a slope of 5/3. So if I go up 5 over 3, I end up at the point 3, 5. So I think that I'm going to use the point 3, 5 in my check. Now let's look at the axes. The horizontal axis is the 15% trans fat grease amount, and the vertical axis is the 23% trans fat grease amount. So this 0.35 is telling me that Uncle Jeb is using 3 gallons of the 15% trans fat grease and 5 gallons of the 23% trans fat grease. Let's put those numbers in a table and make sure our answer makes sense. So we've got 3 gallons and 5 gallons of the two types of greases. If I have 3 gallons of 15% trans fat grease, the amount of trans fat is going to be 0.15 times 3, which is 0.45 gallons. If I have 5 gallons of 23% trans fat grease, the amount of trans fat is going to be 0.23 times 5, which is 1.15 gallons. Now, when I add these two grease amounts together, I end up with 8 gallons total of grease. I want those 8 gallons to be 20% trans fat. So what is 20% of 8 gallons? Well, that would be 1.6 gallons. Do the two amounts of grease that I added together, do they contain a total of 1.6 gallons of trans fat? 0.45 gallons plus 1.15 gallons? Guess what? That's 1.6 gallons. My answer checks. Here I've gone ahead and shown the graph again, and I've indicated a little slope triangle on this graph. And we're being asked, what is the slope of the line? And to state the contextual meaning of the slope. Well, I can see connecting these two green points that I have a rise of 5 units and a run of 3 units. So the slope of this line is a rise of 5, and the units there are gallons, over a run of 3, and the units there are also gallons. So technically, this slope is 5/3 gallons per gallon. This time, the unit doesn't give me as much information as it sometimes would because I have the same unit on the two axes. So I need to keep it really clear in my head that the rise is associated with the 23% trans fat grease and the run is associated with the 15% trans fat grease. I even think I'm going to write myself a little note that the slope is telling me 5 gallons of 23% trans fat grease over 3 gallons of 15% trans fat grease. That will help me write the contextual meaning of the slope. The contextual meaning of this slope is that to produce 20% trans fat grease, Uncle Jeb needs to use 5 gallons of 23% trans fat grease for every 3 gallons of 15% trans fat grease used. One last example today. This time, it's all about Marge. Marge is in charge of wieners. Specifically, Marge needs to buy wieners for her son's Bobcat Scout jamboree. The boys all like the basic pork part wieners, but the moms tend to prefer turkey wieners. Marge has a total of $24 to spend on wieners. Lucky for Marge, she lives in a tax-free state. Figure 1, which is on the next screen, shows a graph connecting points that represent various combinations of pork wiener packages and turkey wiener packages that will result in Marge spending her entire wiener budget of $24. So here's our wiener graph, and it looks to me like we have the number of turkey packages on the horizontal axis and the number of pork packages on the vertical axis. Let's ask some questions about this graph. Like, what is the unit cost of each type of wiener package? Well, I'm looking at this graph, and I see that we have integer coordinates for both of our intercepts. So I think we can use our intercepts to figure out the unit costs. I pre-printed a little table here to give me some room to kind of sketch out what the intercepts are. When t is 0, it looks to me like the value of p is 20. And when p is 0, it looks to me like the value of t is 16. What does this tell us? This tells us that the unit cost of the pork wieners is, well, she'll spend her entire $24 on 20 packages. So that simplifies to $1.2 per package. How about the turkey wieners? The unit cost of the turkey wieners is, she'll spend her entire $24 if she purchases 16 packages of turkey wieners. So that simplifies to $1.5 per package. So now let's go ahead and find an equation for the line. Well, the first thing I need to do is figure out what's the slope of that line. Focusing on the two intercepts, I see that when the number of pork packages rises -20, the number of turkey packages runs +16. So the slope is -20 packages over +16 packages, which simplifies to -5/4 package per package. I can also see that the vertical intercept is the point 0.20. So I can just go ahead and write down my equation, that P is equal to the slope, which is -5/4 times T plus 20. Let's indicate the contextually meaningful points on this line. Well, what do I mean by that? What I mean by that is, it doesn't matter how much pull Marge has down at the supermarket, I don't think they're going to allow her to buy a fractional part of a wiener package. So the only points that are contextually meaningful in this problem are the points where both coordinates are integers. For example, the point 0.20 is meaningful. To find the other points that are meaningful, what I'm going to do is execute my rise over run of -5/4. If I go down 5/4, I land at the point 415. If I go down 5/4, I land at the point 810. If I go down 5/4, I land at the point 12.5. And if I go down 5/4, I land at the point 16.0. These are the only combinations of pork wieners and turkey wieners that Marge could purchase and use exactly $24. Now let's turn this question around. Suppose that we were told up front that each package of pork wieners costs $1.20 and each package of turkey wieners costs $1.50. Let's write an equation for the total amount Marge spends, C in dollars, on P packages of pork wieners and T packages of turkey wieners. So her total cost is going to be the unit cost of the pork wieners, which is $1.20 per pack, times the P packages, plus the unit cost of the turkey wieners, which is $1.50 per pack, times T packages. Now let's replace C with 24 and solve for P, and let's make a little observation. Alrighty, so we've got 24 equals 1.2 P plus 1.5 T. To isolate P, I'm going to begin by subtracting 1.5 T from both sides of the equation. That gives me 24 minus 1.5 T equals 1.2 P. Now I need to divide both sides of the equation by 1.2. So that gives me 24 minus 1.5 T over 1.2 equals P. Now, before I simplify this, I think I'm going to use the symmetric property of equality and rewrite this so that the P is on the left. I need to distribute the denominator of 1.2 to both terms in the numerator. So that's going to be 24 over 1.2 minus 1.5 T over 1.2. So when it's all said and done, P is equal to 20 minus 1.5 over 1.2. That's the same ratio as 15 over 12. 15 and 12 both have factors of 3. And when I factor out 3 over 3, I'm left with 5 in the numerator and 4 in the denominator. P is 20 minus 5/4 T. So what's the observation we want to make? The observation we want to make is, by golly, that's the equation of our turkey and pork wiener line. Assuming that Marge stays within her budget, what is the necessary relationship between the wiener cost formula and $24? Well, this might seem like a bit of an odd question, seeing as I've got written right on the screen 1.2P plus 1.5T equals 24. But that's not really the necessary relationship. Marge does not have to spend her entire wiener budget. What Marge does need to make sure happens is that the amount of money that she spends doesn't go over $24. And we can represent that using an inequality. 1.2P plus 1.5T needs to be less than or equal to 24. So a natural question would be, what are some of the meaningful solutions to this inequality? Well, we already saw that there was only 5 meaningful points on the line that satisfy the equation, and since our inequality symbol includes equality, these 5 points would satisfy the inequality as well. But maybe Marge doesn't want to buy any one of these specific combinations. Let's think about this. For example, this point right here, which is the point 415, that tells us that Marge could buy 4 turkey packages and 15 pork packages, and she'll use her entire $24. So it makes sense to me that if she still bought 4 turkey packages, but she only bought 13 pork packages, she'll spend less money than $24. So the point 413 is a solution to our inequality. This is good that there's solutions that are not on the line, because maybe Marge sits down and figures out that she wants to buy 6 packages of turkey wieners. We can tell from the graph then, as long as she picks a point that is on or below the line, her total expenditures are going to be less than $24. Since there is no meaningful point on the line, she'd have to use one of the combinations that fall below the line. This last example is an example of what we call a linear inequality in two variables. That's what lesson 19 is all about. So it looks to me like we're saying toodaloo to Marge's Wieners, and you're saying toodaloo to me.